These are your instructions. As usual, just follow the PowerPoint. Make sure the sound is turned up on your device so you can hear the narration. Your instructions are in yellow boxes on the relevant slides. Remember, if a slide asks for homework, don't forget to send it in via Show My Homework. And if a slide asks for Educate to be completed, don't forget to do it by the date given on the slide.
This is our starter activity. Have a look at these three pictures and see if you could work out what they have in common. Pause the recording here while you think. There's three things really that you might have noticed about these three pictures that they have in common. One, we've just finished talking about moments, so you could have noticed that they all involve moments or some kind of turning force. The second thing you might have noticed is that they all have some kind of fulcrum or pivot. And the third thing, which you may or may not have noticed, is they're all examples of something we call a lever. By the end of this lesson, you should be able to explain how gears and levers transmit the turning effect of a force. Before we go any further, just remind yourselves of the key points from our lesson on moments. Remember that a moment is the turning effect of a force, and we could calculate it using this equation: moment equals the force times the perpendicular distance, m equals F times d. To see how a lever works, we can have a look at this situation. This is a pivot or fulcrum, and this is our lever. On the left-hand side, we have a heavy weight exerting a force downwards, which we're going to label W. And this is balanced on the right-hand side by a force of 10 newtons. Now the lever is in balance, the system is in equilibrium. So that means the clockwise moments must be equal to the anti-clockwise moments. So if we look at the right-hand side first, the clockwise moments are 10 newtons times 1 meter, which is 10 newton meters. And this must be matched by the anti-clockwise moments from the left-hand side. So W times 0.2 meters must equal 10 newton meters for the system to be in balance. That means that W is 50 newtons, because 50 times 0.2 equals 10. Now that means that we have used a force of 10 newtons to lift a weight of 50 newtons. We say the lever has multiplied the force from 10 to 50 newtons, or by 5 times. Levers make it easier for us to do work. They increase the distance from the pivot at which the force is applied, meaning that less force is needed to get the same movement. Levers are therefore known as force multipliers. They reduce the amount of force that's needed to get the same moment by increasing the distance. Now, examples of where this has been used include the pyramids, which the Egyptians built using simple levers. And this is also the reason why Archimedes, the Greek, once said, "Give me a lever long enough and a fulcrum on which to place it, and I shall move the world." You see levers in action all around you every day. Some of them are very easy to spot. If you look at this first example, it looks just like the ones we've been studying. The pivot is in the middle, the force is being applied on one side, and the load is on the other side. But this one, the second one, the wheelbarrow, is also an example of a lever. But what's happened here is the pivot is on the left-hand side, and both the force and the load are to the right of it. However, it is still an example of a lever. And here's another example. This is two levers working with a common pivot, and we call that a pair of scissors. Levers are classified according to where the pivot, load, and effort are relative to each other. Here are some examples for you to look at, but you do not need to learn the different classes. The second part of this lesson is about gears. Gears are simple machines used to transmit the rotational effect of a force from one place to another. In its simplest form, a gear is just a circular disc with teeth cut around the edge. These teeth interlock so that turning one causes another to turn in the opposite direction. Common examples are the gearbox in your car or the gears on your bike. There are only a few things that we need to know about gears. If you look at this one, where you have a small gear and a larger gear, labelled A and B, gear A turns in this direction, and the first thing you need to know is if gear A moves clockwise, then gear B must move anti-clockwise. The second thing you need to know is that the size of the force exerted by gear A on gear B depends on the distance from the pivot to the edge of the gear. Because gear B has twice the radius of gear A, the turning force is doubled. Answer these questions in your book. Answer these questions in your book. Answer these questions in your book. Send photos of your answers to the questions on slides 11, 12 and 13 to Mr. Rahman by Friday the 15th of May. Thank you.